Question 56 is a really common type of ACT problem. It falls into a topic known as permutations and combinations. It's asking you for a 4-digit code. So, sorry, a 6-digit code, my bad. 1, 2, 3, 4, 5, 6 positions. This can be a number 0 to 9. This one can be a number 0 to 9. And these ones can be letters. Sorry, I should have just written A to Z there. So the thing about this question, the numbers are allowed to repeat, but the letters are not allowed to repeat. So this is a specific topic known as permutations and combinations. If you don't know it, don't worry, because it's usually pretty easy to figure out these topics kind of by yourself, but you have to know what methods to use. So I would draw a diagram out exactly as I've done with each of the spots. You don't necessarily have to write how many options you have, because that just might take up too much time. So think about how many options you have here. You have 10 options for what to put in this spot. It could be any of 10 things. You also have 10 options to put in this spot, because these two things can repeat. So whatever you've put here doesn't affect what you've put there. Still 10 options, same thing. Now for this spot, you choose a letter. So you have 26 options for that. Now the letters may not repeat, so whatever you picked for the first spot you've used. That means you have 25 letters left that you could use here. You have 24 letters here and 23 letters here. So just to go through that again, 26 letters in the alphabet, you have 26 options for your first spot. You've used one of those here. Let's say it's A, but it doesn't matter what it is. Now you have the other 25 letters of the alphabet you can choose from. Now you have 24 letters once you're choosing for this spot, now you have 23. So the total number of options is these numbers all multiplied together. So here's a really useful general rule for probability as well while I'm at it. If you're choosing something, or if you're trying to figure out like how many you have or something like this, if it's this and this, like in this case, so we need to pick this number and this letter and this letter and this letter and this number, then we need to multiply those options together. If it were or, as in you can have a letter or a number, you would need to add these together. Think about that carefully. If you have to choose a letter or a number, there are 26 letters and there are 10 single-digit numbers, so that means you have 36 options total. So in this case, let's just do that calculation quickly. That's 10 times 26 times 25 times 24 times 10. Okay, that's 1,560,000. Okay. Now, this question is actually not asking us directly for that number. It's asking us for which of the following expressions gives the probability that a randomly selected identification code contains the word math. So basically, we're looking for a specific 4-digit sequence. Now, there's only one way in all of our 10 spots. If it has to say math, oops, sorry, I didn't mean 10 spots, I meant 6 spots. If we've got 6 spots, but the letters have to say math, then those are our only options. There's only one way we can put an M here. That's it. We just know what it is. That makes, yeah, we've got one option. But we still have our 10 options here, and we have our 10 options here. So in total, there's still 10 times 10 different options that we can have for this. So our probability is the number of options that we are interested in over the total number of options, which is always true for probability. How many zeros do I have? 3, 4 more. Okay, good. Divide by 100. Now compare this to your answer choices. You've got 1 over 15600. Okay, I did a stupid strategy thing and I didn't look at my answer options. I've now gone too far because none of the answers are at all simplified. So we need to look at we need to kind of look at what we had before to get to these numbers. So this 100 was 10 squared. So you should look for something that has 10 squared in the numerator. That's the first 3 options that you're given. Then this was 10 times, okay, I'm not going to write the whole thing out because you can see it at the top here, 10 times 26 times 25, 24, 23. So we need to look for an answer that has a denominator of that. If I just check the answers quickly, I can see that that is choice G, which is the right answer.